Hello, everyone. Thank you for joining today's webinar. Title is Data Access with Spring, and we're going to be talking about JDBC, JPA, and accessing those technologies over REST. My background is I've been committing on the Spring projects, several of them, for many years now, coming up on a 10-year anniversary. And along the way, I founded Spring.net, and on the most recent activities I've been doing is I lead the Spring Data family of projects. With me today, for the latter half of the webinar, is John Brisbane, and he's my colleague who works on the Spring Data REST module. As I'm sure everyone on this webinar is aware, there's been quite change in the data access landscape over the past 6 or so years. Relational databases are still important and quite predominant in the enterprises, but a variety of new data access technologies or databases have emerged, and they're solving problems that relational databases can't. The things that relational databases are not addressing very well are matters relating to scale, and also the data model itself, the relational data model, is being replaced in certain use cases with graph or column-oriented or document-style databases. But there's no one-size-fits-all solution anymore, so the term polyglot persistence is becoming more prevalent, and this refers to applications that use a mixture of database technologies, usually relational plus something else. And how this relates to Spring is that Spring has always provided great data access support from the beginning. There's features such as transaction management, the portable data access exception hierarchy, helper class JDBC template, which I'm sure many people are familiar with, as well as the support it had for Hibernate, then transferring to JPA, JDO support, IBATIS, and even recently in this realm we've added support for declarative caching of method invocation inside of Spring 3.1. And to keep that legacy up to date, in 2010 it was decided to start a new effort to refresh Spring's support for data access. And this was in relation to new databases that were emerging, but also to improve its relational database support. So the Spring Data mission statement is to provide a familiar and consistent Spring-based programming model that covers the areas of big data, NoSQL, and relational databases, but also keeping the individual store-specific features and capabilities intact. So as it relates to NoSQL data stores or big data, we don't aim to provide one lowest common denominator solution, but aim to provide easier access and easier use to all of the rich capabilities of those data stores. We won't be going into that area, of course, in this talk, and we'll be focusing more on what Spring offers for relational databases. The big picture of all the technologies that we offer support for inside of Spring Data are relational in terms of JPA and JDBC. The project in Spring Data that relates to JDBC is called JDBC Extensions. For NoSQL, you can see there's a rather long list of NoSQL technologies that we support. And what we will be covering in this webinar are access methods, namely how to use Spring Data JPA to implement data access repositories, the use of the QueryDSL project, as well as accessing repository information over HTTP REST. Big data is another area covered, but we'll be discussing that in a webinar on December 13th. So to go over some features in the core Spring Framework JDBC stack that you might not be familiar with, I've taken a few sample features here. One thing to keep in mind is that the SimpleJdbeInsert template class that was introduced by Rod Johnson quite a while ago made use of several Java 5 features to simplify the use of the classic JDBC template. That's now been deprecated and as of Spring 3.1, and all of its functionality has been moved into the existing JDBC template and named parameter JDBC template, which we'll be talking about in a minute. Other features that you might not be so familiar with are the JDBC insert helper class as well as the JDBC call helper class, and we'll cover those in a moment. So the JDBC support has a named parameter JDBC template, and one of the main features it offers is that instead of using named parameters, instead of using question mark placeholders for parameters, you can use names instead. And if you've ever coded with JDBC and had many parameters, usually you can have a soup of 8 to 9 question marks, and it becomes a little bit hard to keep track of what's going on. So if you look below in the code snippet, there's a SQL statement there, and at the end it says where name equals :name. That is used as an alternative instead of using equals a question mark, question mark. Makes the SQL statement easier for you to read and to pair up in your mind, not just by position of the question marks, how to replace the parameter values. So to actually pass in values for these parameter placeholders, you can pass in a map, or you can use one of the SQL parameter source implementations. One that's particularly handy is the bean property SQL parameter source. And this allows you to have a mapping between the Java Bean property names and the column names as they appear in the class. This is great for quick development, but if you want the maximum of efficiency, you might code it by hand. Similarly, the Bean property row mapper is a way you can retrieve information out of the database and map a result set into a Java object, and it follows similar conventions of using columns to map to Java Bean property names. The other feature of SQL parameter source that's useful, but not shown down here, is that you can specify the SQL data types that you might want to use for each of those named parameters. So the basic flow is you create a new named parameter JDBC template, specify your SQL using placeholders with :name, specify the values for those properties with an implementation of the SQL parameter source, and then use a familiar method on the template, such as query for object, passing in the SQL statement, the parameter values, and then a row mapper, for example, or a result set extractor to map the class from a result set into a POJO. SimpleJdbeInsert Insert is another helper class that you can use for inserting data, which traditionally, if you were using Spring, would be done through a keyholder class and vendor-specific coding to create a prepared statement. SimpleJdBC template simplifies this by collecting table metadata, so it knows how to collect the required information of the data types around the table and the column, and also knows the correct syntax to use in creating a prepared statement in order to extract the key. So this code snippet here shows you can create a new helper class JDBC insert and specify the table name and what the key is that you would be used to retrieve a generated ID value. In this case, it's called ID. Then we call execute and return key on that helper class. And here again, we're using this Bean property SQL parameter source, which will automatically take the Bean property names inside the customer object, and as long as the table name, the column names map to those Java Bean property names, they'll be inserted into the table row. Once that returns, we have the new ID as was generated from the database, and we can now set the ID on the customer object. Similarly, with stored procedures, if you're doing this even in Spring, there's a fair amount of tedious setup work you have to do in order to, one, know all the parameter names and also know their directions if they're in or out. And similarly, invoking them requires vendor-specific coding. The SimpleJdBC call class simplifies you invoking stored procedures. Again, it uses table metadata to figure out the data types of the in and out arguments for your stored procedure. So the code snippet on the bottom shows how simple this can get. You can create a new instance of the SimpleJdBc call class, specify the procedure name and the data source, and then execute it, passing in the collection of arguments. In this case, we're passing in a string that's used as a prefix for generating a random customer number. So moving on to the Spring Data projects, there's a project called Spring Data JDBC Extensions. In this project, there's sort of two categories of support that we offer. One comes from a product that we used to offer in Spring Source commercially, but now have released it as part of this open source project that relates to advanced uses around Oracle. And it covers Oracle RAC, Oracle Streams, its messaging product, as well as additional features just for Oracle as you traditionally know it. The features around Oracle RAC are to have automatic fast failover when a connection drops from one of the databases in the cluster, simplified configuration around the messaging functionality, and support for, it's a quite nice feature I think of this product, to have a single transaction manager that's responsible both for the database commit and for the transactional messaging, which with another product would otherwise require usually a two-phase step and two-phase commit protocol step and be less efficient. As it relates to using Oracle, the pure database itself, there's easier access to native types such as XML, arrays, and structs, as well as more extensive APIs for customizing the connection environment in Oracle itself. There's quite a lot of extra features there. But one other interesting area that we'll talk about a fair bit in this webinar that Spring JDBC Extensions project offers is around QueryDSL. So QueryDSL is trying to address a pain point that's quite common in developing data applications, namely that queries are usually expressed as strings within code. And as I'm sure we've all seen, that this can be quite error-prone. If you make a mistake in your query syntax, you usually only find out about it when you run the application versus when you develop it. So it's not a compile time concern, but it's a runtime concern. In addition, of course, you have to remember your query syntax, which changes depending on your backend, JDO versus JPA. Or similarly, there's usually a lot of verbose parameter handling that you have to do for binding values to parameter names. So the QueryDSL project is an open source Apache 2.0 licensed project. You can find more information about it at querydsl.com. And what it provides is type-safe queries for Java. For those who are familiar with .NET, you can think of it as Java's version of LINQ, the language integrated query that is offered as part of the .NET framework. It offers a very compact and intuitive syntax. And what's very nice is because queries are now inside of a DSL, at compile time in your IDE, you can get valid queries. So if it compiles, basically your query is valid. But also you get code completion syntax, and whenever you hit dot, on this DSL class, you'll see your field names, and you can create predicate expressions quite naturally. Another nice feature is that it provides a consistent query API across a wide range of data stores. So this relates to normal SQL, but with JDBC, but it also extends to JPA, Hibernate, JDO, Lucene, Mongo, Neo4j. It's backed by a company named Mysema, and you can find more information about their company at their web address below. So how do you use QueryDSL? It's used by incorporating a code generation technique inside of your build process. And it generates a query meta model either of your tables in the case of JDBC or in domain classes if you're using object relational mapping. So for SQL, here's an example. You create the QAddress class, which is generated from the code generation. And then you select basically a dialect. In this case, I'm using HSQLDB. And now comes the interesting part. I'm going to create a query class. And here's where you start to see some of the fluent syntax that you can use with QueryDSL. I'm going to say it's from the address table, where the address city is equal to London. So in this case, that predicate expression, when you're typing it inside your IDE, you get to say address.city.equals, and then you put in the value. And then you can continue to build up an expression by saying dot, and address city not equal to, or zip code equal to, such other number. In the raw QueryDSL product, the way you execute this query is by calling the list method, passing in the class that you'd like to get it mapped to. This QBean class is QueryDSL's sort of equivalent of Spring's row mapper. And then the list of arguments you have here are those values of the address table that you'd like to have mapped into your address class, in this case, street, city, and country. So what we've done inside the Spring Data JDBC Extensions project is to merge this functionality with JDBC template. So it should be no surprise then we have a class called QueryDSL JDBC template. So it's a wrapper around core JDBC template that supports using these SQL query classes from the QueryDSL project. It integrates with Spring's transaction management, and it sets up some of the basic things such as detecting the database type, so the dialect for using QueryDSL. But more importantly, instead of using that QBean infrastructure, you can reuse your existing knowledge of row mappers and result set extractors to map your result sets back onto POJOs. So similarly, QueryDSL offers other convenience mechanisms that are fluent as well for doing insert, updating, and deleting. So here's an example of how that works. You create an instance of the template. You use the metadata generated class that here is called QAddress. And with the QueryDSL template, you create a new query, use the same predicate expression as before. However, now when you're executing the query on Spring's template class, you pass in the query, a row mapper, and then a similar set of values that you, table columns that you want mapped back onto your address class. I don't show the complete full syntax that is offered by QueryDSL, but you can go on their website and look. There is support for associations, so you can do left joins, right joins, standard joins, inner joins. All those type of things that you're used to is very powerful, very flexible to create your queries as compared to using standard strings. So the next topic I'd like to talk about is the concept in Spring Data projects around repositories. So repositories are basically your data access layer that's mapping from your data source, usually a relational database, into objects, your domain objects. And the goal of Spring Data repositories are to remove the busy work of you creating a repository. So for example, here we have a traditional case of a customer, and we have a customer repository. And we have three methods here: find one, save, and find by email address. Below on this code snippet, we see the basic mapping, JPA mapping annotations that you would use to map this customer object that has a set of addresses and an email address into a database. And this is stuff that you've probably seen before or done before. The traditional JPA implementation is to get hold of an entity manager, and in the case of find one, call the find method, passing in the customer class and the ID. In the case of save, doing this traditional check to decide if you should persist or merge the customer. And then in find by email address, using the entity manager to create a query, set the parameters, and then execute that query to get a single result. So this type of stuff is things that are done over and over and over again. And the first step of the Spring Data Repository support is to remove this sort of boilerplate code that you write over and over again, in addition to going beyond this and providing additional functionality such as paging and auditing, which we'll show later. So the way we remove the busy work of building a repository is to follow a simple recipe. You already have your Pojo. For example, if you're migrating an existing project to use Spring Data Repositories, that's annotated with JPA annotations, or you have to do that step yourself just as you would have done before. Then you extend the Spring Repository Marker interface or use an annotation to indicate to our infrastructure that this interface is going to receive an implementation from Spring, that you don't have to write yourself. You add finder methods such as find by email address, find by name, and then you configure Spring to scan for these repository interfaces, and it will then create the implementations for you. So you're only writing the interface in the base case. Now you're able to use those implementations in your services as you would normally. So here's the same example again. I have the customer repository. It's extending the Spring Data Repository Marker interface with the domain class and the type of the ID, in this case a long. Alternatively, I can use an annotation, if you don't like the interface, to provide that same set of information. Then to inform Spring that we would like to have an implementation generated automatically for that interface, we can use the enable JPA repositories annotation, or with an XML namespace, the JPA:(repositories) element, passing in this case, a base package where we would like to scan for interfaces. So as you would use it normally, you just wire these repositories into your transactional service layer and use them as you would normally. So the one thing that's very interesting to understand is how do we implement the method find by email. And what we're doing there is something that's common in Grails and the Ruby world is through a set of conventions in the method name, we derive the JPQL query from that method name. So in the case of the find by last name and first name, this corresponds to a JPQL snippet where x.lastname is equal to placeholder and x.firstname is equal to placeholder. And you can see we support quite a large variety of combinations here. So your first order finders, find by name, find by email, find by age, find by active true or active is true. All of these you can handle a very straightforward way just through method naming conventions. Another interface we provide that you can use as a helper to get started is one that does create, update, and delete. So you can save an entity, find, do a count, and have a variety of delete functions. So if you implement this interface, you'll get all of this behavior out of the box. Going one step further in terms of removing boilerplate code that you would have to write revolves around paging and sorting. And this is where I think a lot of people tend to do more ad hoc development around paging and sorting than they do in the basic CRUD methods. So we provide a sort class and a pageable class and a page class for you to use out of the box to get the functionality around paging and sorting. So in this case, we have a paging and sorting repository. You can have your repository or DAO layer implement that interface. Oh, here I actually made a mistake. It should say extends paging and sorting repository. And then you can say find by first name like, give it a string, pass in your paging requirements like what page you're on, first page, second page, how many results per page, and then be returned with a page of person objects. And we've taken care of how you map this into the web tier by having for example, a pageable argument resolver in Spring MVC, and this allows you to convert request parameters in the HTTP request to the pageable object in your MVC controller method signature. If you're going to have queries, for example, that are very long, right, like by first name and second name and phone number and 5 or 6 things, you might find it easier to not make a method name that long, but instead you can override that derivation logic from the method name to the JPQL query by using the query annotation and putting inside there either a reference to a named query that exists in a properties file, externalized, or the JPQL query in the annotation itself. So there are quite a large amount of other features that you can get at inside the Spring Data JPA support. There's support for specifying the transactional metadata, so how the lock mode works, query hints, and so on, as well as features around auditing and CDI integration. And one last feature that I'd like to show is its use with QueryDSL. So QueryDSL, as it compares to the JPA2 Criteria API, we find is quite easier to use, and this slide contrasts the two approaches. In the case of JPA Criteria API, the way in which you specify what you'd like to have your query is usually in the form of equals, property, and value. As you can see here with the builder, you say builders equals, and then the property is gender, and the value is male. Whereas most people think, well, property equals value. So on the upper part of this slide, the code snippet is the JPA Criteria API, which is also a code generation approach where the person underscore is the metadata class that's used to get at the actual fields that you're mapping into the database. On the bottom side, we're using the QPerson class. That's the code-generated class that represents the person object and can be used to generate a query. And here you can see how naturally it reads from that. I like to do a query where men's gender is male, where men's relationship status is single, and similarly for women. So that predicate object in the where clause is good to keep in mind, because that predicate is what we use inside of the Spring Data Repository support for QueryDSL through the interface QueryDSL predicate executor. And here you can see there are a series of finder methods, each taking a predicate as well as integrating with our pageable support. So if we have a product repository that implements this QueryDSL predicate executor, then you'll be able to specify predicates in the, say, the find one method here, where I have the product, that's the generated class, metadata class, .name is equal to iPad, or I can specify the predicate as assigned to a variable where the description contains tablet, and then pass these predicates off into the find all method. So one last thing I'd like to cover is around the tooling support that we provide in STS for this, and there's similar tooling support in IntelliJ as well, the last two versions of IntelliJ. Namely, if you're sitting inside your STS IDE and you have your project here which has products and customers and addresses, if you were, for example, wanting to create a product repository, in this case we're extending CRUD repository, and you say, I'd like to find by something. In this case I'm saying find by description containing. However, I've made a typo here, and I've left out the I in description. So the tooling knows that the product domain object does not have a property with this typo of description, and it will highlight it as an invalid query. So you have this additional tooling support. So you're not just typing, sort of naked inside of an editor. Similarly, if I now want to create an order repository, here you see I have customer, billing address, and shipping address and line items being mapped. When I'm actually typing out the method name, I can say find by, do control space, and now I'll get hints for the properties that are being mapped, billing address, customer, line items, and so on. So you could sort of click your way through generating this. So here I chose billing address, but I can also now let's say billing address and something else, line items. And so this tooling makes it simple to not make mistakes or catch mistakes as you're typing out these method names. So now what I'd like to do is pass over the virtual webinar stick to John Brisbane, who's going to cover how you can access the data from these repositories through HTTP via REST. John?
Okay. Thank you. I'm going to share my desktop real quick, and we'll just dive right into some slides. And okay. So we're going to take the repository portion of what Mark was talking about and apply HTTP REST semantics to it with as little code as possible is the goal. We're just kind of leveraging off of the JPA repository, CRUD repository. You can create repositories in different ways and annotations. You don't have to implement all the methods. But since we're doing HTTP and we don't know exactly what you're going to want, at the moment, you're going to need to extend the CRUD repository or paging and sorting repository interface if you want to export your repositories through the REST exporter. You get a lot of extra methods on that, and there's ways to turn some of those off from the web interface as well. So basically, we're mapping a put and a post to a save method. All your finder methods are mapped to the get verb, and then of course delete. It's pretty obvious. And then there is the issue of when you're dealing with the HTTP and the web is what format do you transmit your data back and forth in? And JSON is a ubiquitous format. It works from the browser JavaScript end. It works machine-to-machine communication. And HTTP obviously is a very good choice for RPC-like mechanisms because it goes through proxies, and there's lots of steps to support it. You can use curl, et cetera, et cetera. So we've just pretty much standardized on JSON as the wire protocol, if you will, of how to send entities back and forth. And there's a few additions really to how you deal with JSON when you're working with the exporter, but at a higher level when you're working with REST services in general. So we've got JSON-P support and JSON-P plus E, which I'll kind of talk about a little bit later, but basically that allows you to just add a callback equals JavaScript function reference on the end of your URL, and then when the data comes back, it's wrapped with a call to that JavaScript function so that the client gets it immediately executed. So that's built in as well. So what we're talking about at a higher level, this ridiculously academic term here, this HATE-OAS, hypermedia as the engine of application state. There is no better acronym at the moment, but basically the idea is the hypermedia portion being discoverability, meaning if I have a set of REST services exposed on the web or internally or however you expose those, and I, as a client, issue a GET to the root of the resource, I should get a list back in some fashion of the things that I'm allowed to do, and different REST services implement this in different ways. The way we do it in the REST exporter is to send you back a list of links, and we kind of take a cue from if you've done HTML, when you reference an external style sheet, there's a link element in there. So we kind of have taken a page out of that book, and these links have different meanings. For example, there's a self link, and so you would expect the self link to refer to the entity's root URL as to where do you go when you want to update or delete the object, etc. And then there can be other kinds of links that have different meanings. Linked properties have associations are represented by links. and there's searches and things like that. So we'll cover that when we start looking at the JSON stuff. But for the moment, basically, the simplified version of this is we take the Atom XML element link, which has a rel and an href attribute, and we kind of transliterate that into JSON. So any object that has a rel and an href property, and of course the href being the full URL to the resource we're referring to, and the rel being an application-specific identifier, a key, if you will. It doesn't have to be you don't have to come up with a separate rel for every single resource you have. It can be based on a type. So if you have a resource that offers a type of action, then you can give that particular resource a rel of that higher level value. So in the REST exporter, we'll show you a little bit about how we approach this, but we don't give individual hrefs throughout our services a unique rel value, and I'll show you what that looks like in a second. You can use this library that we're using, Spring Hate OAS. If you go to GitHub, you'll see some examples of how to use that, and there's helper classes in there that you can implement. There's link builders, and there's some abstractions that we use. Resource support is in there. There's resource processor so that you can do some after processing, and those you can use in your own application. We're just using them here in the REST exporter to have a standard base foundation on which to build these resources and links and things like that. So basically, if you take your repository configuration, your base configuration that contains your data source and your repositories and everything, and get that loaded up before you load your web stuff, then you can load the special exporter servlet we have there, which is just a convenience kind of wrapper around dispatcher servlet, or you can set up dispatcher servlet with the repository REST MVC configuration references pulled into your own configuration if you want to add components, listeners, or event handlers, things like that. The exporter itself is just a Spring MVC application. It just has certain components set up in certain ways. So whatever you can do with a Spring MVC application, you can presumably do with a REST exporter application, including running the REST exporter alongside your application, so that maybe you want to implement a particular REST service yourself in your own controller. You can do that. You can use the Spring Hate OAS library to give output that is the same as what the REST exporter would do. So there's some interaction there between your traditional Spring MVC and the REST exporter, which is just a traditional MVC application. So if you're using the latest version of Servlet 3, and you've got web application initializers, then you can set up your web application in Java code without using a web.xml. In fact, the example thing here we're not even using the web.xml. That's one of the nice little things about it. But this is just a pretty simple context loader listener set up with our custom configuration class, and then we add our dispatcher servlet with a reference to our REST configuration class, and that looks like this. Pretty straightforward. Nothing really fancy, but we will take a look at the application config class, and we're using our enable JPA repositories annotation to pick all that stuff up, component scanning, so that we will find our repositories over here. We can override certain things of the repository REST configuration, and there's a lots of ways to tie into it and configure it. We won't really go into details on that because there's just not enough time to do it. But suffice to say that this repository REST configuration can be tweaked to suit your deployment environment. Go back over here to our REST configuration. Now we don't have anything in here yet. We just are importing the MVC configuration and letting the default behavior take place. So we have a couple entities. I'll close those out. A couple entities to look at. We've got an add like if we're going to set up an ad server, a Google ad here, we've got a pretty standard JPA entity with versions. We've got a little bit of validation going on there, which we'll talk about in a little bit, and the campaign object to kind of aggregate the various ads, has a name, whether or not this is active, and our one-to-many relationship to the ads. I actually have I have it running here in a terminal. So what we're going to look at real quickly to show you what the services actually look like is we're going to use what's called the REST shell, which is a new utility we have. It's on our SpringSource GitHub, and it basically just lets you have a kind of a terminal-like experience for HTTP. But if your services comply with the Spring 8 OAS expectations of having a links element and things like that, then you will be able to do things like discover what resources are available and have them printed in a little list, and then have that rel value cached for later use, which could be really handy if you're down in a session and you don't want to have to type out the entire URL all the time. Or you may not even be at a point where you want to use a relative URL. You can just refer to this rel value later, and you get tab completion and things like that. This is built on the Spring shell, so you just hit tab there, you get a list of what commands are available, and there's help on each one of these to help you kind of figure out how to use that. So that's kind of like a CD. We do a follow ad, and then we can list the resources that are available. See, there's two of them, and a search. We look at add search. We've got one finder method in there, which we have in our ad repository. Haven't updated since I recompiled that, but we'll show you how that looks when I restart that. All right. You can use Homebrew to install this REST shell. You can download the binary. Basic interaction is discovering of resources, changing your hierarchy, listing of available resources, and that's just kind of how we go about doing our interaction. So there we've created a finder method, find by active is true, using the using the terminology here in our method name to decide how the query is going to work, and we should be able to do that same thing here. Hopefully things are set up to where it will work correctly. Up over here. Start it up. Okay, now here's our finder method, and all of our finder methods are going to be exposed under the path to the repository and this search, word search, and then by default the name of the finder method. So if we call that, let's do it get on. There we can get tab completion on our rel since we've discovered those services. And here we get it runs our finder, and it returns us a JSON document, which is empty of links in this because this is a search, and it has a content section, which is an array of our objects, and then this is an object here that is returned from the search, and there's a self link that that all objects should have. We go up. Let's follow. We have campaigns to look at as well. Oops, I misspelled it. Yep. All right. So if we just get the entity itself, we see that we have the self link, which we should always have, and then we have this particular one here, campaign, which refers to the repository this is exported under, campaign with a capital C, which is the simple class name of our entity, and then the property name. So if you remember over here in our entity, we have this one-to-many association called adds. And so that one-to-many association is not inlined in the JSON. That one-to-many association is referenced by a URL of its own. It has its own resource. And if you do a get on that, you'll see what you'll see the content inline here. This is the add that is associated to that one-to-many relationship. You want to change the path of your REST resources, you can do that by adding a REST resource annotation. Got a path on it. Now we've actually changed how this was exported. If you remember earlier when we ran this, we had this find by active is true, which is the method name that it's exported under. And now since we've changed the path, it's exported under a different URL, and the rel value is also different. So that can be handy for distinguishing services and kind of changing the name of how they're exported by default to fit the feel of your particular application. Resource processors allow you to alter the resource, and if you were to look in the Spring 8 OAS library, you'd see this resource processor class, you'd see the resource class, and so basically just define some of those in your application context, and there's some type magic that goes on to match up the resource of a particular entity, and then it will hand that to your processor. And then you can do things like adding links and checking various things. If you look on our add entity, we have a version defined. So how that maps to HTTP semantics is as an E tag. It won't show up as a normal property unless we tell it to. By default, we hide version and ID for philosophical reasons. There's a long discussion that we could have about it, and that's beyond the scope here, but just suffice it to say the version goes in as the E tag, and then on your next HTTP request, if you pass the if none match, it will give you a not modified back if the version hasn't changed. And then you can expose the version if you need that in your own client. You need to track the specific version to match things up to make sure updates are happening correctly. You can do that by adding the REST resource annotation to it. Validation, JSR 303, you can add messages directly on there, or probably better, set up a message source for internationalization in your application context, and then you can use keys in your validation, and the REST exporter will take care of converting those errors, if validation errors occur, into a JSON block so that you can handle those errors as JSON in, say, JavaScript if you want. You can also use a Spring validator, which allows you to validate specific domain classes and allows you to do more complex validation than what you could do as like if something exists or a certain length or whatever. For example, you could have a list of bad words that you want to reject any content coming in that has those words in it, and you can do that more complicated sort of validation using a Spring validator. And you just define those in your application context, and they will be picked up and applied at the appropriate time. there are events that happen for every update, delete, link update, link delete, and so you can handle those in your application if you need to. If you need to know when a particular entity has been saved, or like after an entity is deleted, you might want to go do some other work. You can just define a handler for that, and that's pretty simple. We've just got our component on there. We're telling it this is a repository event handler for the add entity, and then whenever the after save event is fired, it will execute the method that has this handle after save method on it, passing us our add instance that we're interested in. The JSON support, pretty simple. You just add a query parameter called callback. That's configurable. If you want to change it to something else, you can do that in the repository REST configuration bean. The addition that we JSON generally speaking, if a request to a resource using JSON results in a unrecoverable error, like a 500 internal server error, or 400 or something like that, your JavaScript function isn't going to be called because of the way the AJAX works in the browser. It processes it a little bit differently because it's a failure. So what we do with the JSON PE is if you have a property set for an error callback and you've passed that URL parameter, then the REST exporter will capture fatal errors. It will turn them into a 200 OK and send back a response that is a JSON response to call your error handler whenever that happens. So that way you can do a full single page app with using JavaScript and catch errors and things like that without having to go through some hoops as you normally would to do that sort of thing. If you're running behind a proxy, you can set up the base URI that links are generated as, because it's going to be different than what the server thinks it is, because the front URI is going to be different. You can set that up in that repository REST configuration bean, which has a lot of different tweaks that you can make on it, and I'll leave that as an exercise to the listener to figure out what that is. Of course, you can do single page apps. You can do knockout.js here. We've got just a little bit of JavaScript we've got this URL. We've got our app exposed under this URL in this example, and we're just going to be pulling out that links property, iterating over each of those, and then pushing them up into our knockout object that we're keeping track of. Spring integration, I will show that real quickly. We can create, let's create an add, and we're going to give it some data, and we're going to say the title, and this is not real JSON here, but we're a little bit lax in the REST shell on what we'll accept, just so that save you some characters typing. There's our new. Oops, I'm trying to pull something up. There we go. There's our new one that we've just created. And what we've got in the background, if you were to look and dig through in our logging here, we've got Spring integration set up, and we're actually creating an AMQP message, and we're sending it to RabbitMQ, where it's got headers exchange that's pulling out after save events, and pull these guys out. See, this is the same JSON that we were to get in the browser in an after save event. So if you have some other processes that are out of band and you need to know, that things are happening, you can do this through whatever means you have of doing messaging. In this case, we're using Spring integration and tying those two together using AMQP. And we're got a transformer being there, so we can do the full processing on it. And there, just recently, I just, in fact, the UPS guy was here earlier today, dropping off my my sample copies of the Spring Data book. So it's hot off the presses, as they say, that contains lots of information, Neo4j, Hadoop, Redis, lots of Spring Data examples, and how to the REST exporter. There's a chapter on the REST exporter, how to do that sort of thing. Just Spring Data Access is more on Spring Core and how you can use Spring Core for data access. And then PAX has a Spring Data book as well. And there's some other resources there for you to look at for more information about Spring Data REST. And the REST shell is also on the Spring Source GitHub. There's a binary download, as I say, and you can install it using Homebrew if you're on Mac and you use Homebrew. And there's some information on how to use the REST shell. It's not specific to Spring or Spring 8 OAS. You get the extra goodies like Discover and List if your resource complies to the 8 OAS principles, but it's not a requirement. You can use it for any HTTP interaction. It's just a utility to help you do gets and posts and puts and deletes and things like that, so that and use relative paths all over, so that you don't have to worry about using curl and curl minus v minus h content type blah blah blah. If anybody's done that as a test, how cumbersome that can be to type all that. And there's a lot of capabilities we've got in here. We've even got we get pretty advanced with setting context variables inside the shell. You could do an entire maintenance application using the REST shell and using these commands. So it's great for setting up test environments or just poking around. I'm going to turn it back over to Mark.
Okay, thanks, John. So wanted to wrap up by showing a few other places you can go to get information. The main Spring Data homepage is springsource.org/springdata, and there you can see there are special dedicated landing pages for each project, the JDBC Extensions, JPA, and the REST exporter. The shell itself, right now you can go to the GitHub page and download a binary that works out of the box for you to play with the shell. And in terms of getting started, there's quite a lot of resources available. We're putting a fair amount of effort into that direction. There's a book I'll show you in a moment that has a series of examples, a book that we've written. So that's the GitHub location, Spring-Data book. There's also a Data Kickstart repository, which you can think of as a simplified Maven archetype style way to get started. It's not a sample application. It generates basically a shell of a working application that you're expected to go in and modify. There's a nice example using Spring 8 AOS for a sample application that was part of the book REST in Practice from Jim Weber and Ian Robinson. That's located in our colleague Oliver Girk's GitHub repository. And using QueryDSL JDBC template, there's a port of that done for JPET So that's in Spring SQLfire samples. Upcoming webinars, there's Spring Data as relates to NoSQL on November 29th, and then another one on big data integration on the on December 13th. And there's a few books out now that cover these topics. So, for example, the core JDBC topics like named parameter JDBC template. There's the book Just Spring Data Access. For the QueryDSL template, JDBC template, as well as the REST exporter and the JPA repositories. There's the Spring Data book that myself and the Spring Data team, as well as David Taransky, who is not listed as an author. He wrote a Gemfire chapter. All of us wrote that book, the one in the middle. And there's another book from Packet, Spring Data, that also covers the repositories, QueryDSL, and so on. You should take advantage. There's an offer that we're running with InfoQ, which gives you the JPA chapter of the Spring Data book for free. Just go to bit.ly and then SD-book-chapter. So with that, I'll go through some of the remaining questions with John here. Answered a few along the way. So there was a question, can I get the SQL that is created by QueryDSL, say if a DBA wants to see our SQL? In the case of JDBC, I would imagine, but I'm not sure, there is a logging statement that would generate that. Certainly in the case of using JPA, all of that is going down into the JPA layer, and then the JPA provider often has a way to show you the raw SQL that's going there.
that is well. Also, too, if you use Insight, I know if you have the application deployed in TC Server and you have Insight, like the developer edition that comes with the Spring Tool Suite installed, you can actually drill all the way down to the actual SQL statement that's being sent to the database. So you could do that manually, doing that.
The question here, with traditional JPA and a DAO class, I can inject different entity managers with different persistent context to tie together different data sources. With our Spring Data Repository support, you, as far as I know, would not be able to do that within a single repository class. You would need multiple ones. Okay. Going down. So here's a nice provocative one. If I use all these features now in 2016, if you deprecate all this, what we need to do? What is the migration plan for this after 3 years? So given that JDBC template existed in 2003, and we're ending on the 10-year anniversary, and you can still use it, and it's all open source, and we haven't deprecated it, and we have no plans to. I think Spring has a pretty good story. I think that's pretty impressive. I would like to see another software library in Java space claim that longevity of support. So I think we have a pretty good track record there. And it's much like buying treasury bonds from the U.S., right? You have the faith of the U.S. government. Here you have the faith in Spring Source to provide backward compatibility and support and VMware. So how does Spring support Hadoop? That's one near and dear to my heart. There's a Spring Data Hadoop project. This is also covered uniquely in the Spring Data book. If you just Google that up, you'll see a pretty big reference manual, and there are sample apps as well in the GitHub repository for Spring Data book. Question here, are metafile stubs, how to name them, generated by QueryDSL serializable? It's a good question. I could pop open very quickly here one of those guys and take a look. Let's see. Let's see. Type hierarchy. Quick type hierarchy. Yes, they are serializable. Can the pageable argument resolver discover paging parameters specified in Spring MVC URI template? Yes, that's exactly the purpose of it. There's I think 5 or 4 request parameters that if you register the argument resolver, then in your Spring MVC method, you can use the URI template as well as a variable, and it will resolve into a pageable. I think that answered the question. Let's see. Anything else? So does Spring JPA support configuring data sources with property files? The answer is yes. You configure and bootstrap your JPA provider as you would do normally. Pick your favorite way. As long as it's bootstrapped correctly, then the Spring repository, Spring JPA support will use that. Issue finding 101 build snapshot. I don't know. We'll have to look into that. I suggest to Vinny Carpenter just download the binary package that is on the REST shell GitHub page, and you'll be good to go versus building. But we should sort out any build errors as well.
It's because it requires the Spring Shell fork. So if you go on my GitHub, there's a fork of the Spring Shell I have. Do a Maven install on that locally, or Gradle install locally, so that those artifacts are available in your local repository, and it should compile okay.
I should have completed that up already, so that's a to-do item for myself. Sorry about that.
That will have been into Spring Shell. So.
Yeah. Okay. What else? How does this new JDBC template handle connection pooling, timeout, concurrent access? Everything that you know around JDBC template before carries over. The connection, meaning the data source, and any properties you provide into the data source happen just as well. This is just quote-unquote syntactic sugar on top of your SQL. Everything else you know about JDBC template applies. It wraps around JDBC template. Same thing with portable data access exception hierarchies. Maybe, John, you can talk to, I think you kind of already addressed this one with the question that says, is Spring Data REST appropriate for single-page web apps like the ones that use Backbone.js?
The short answer to that is, yeah, absolutely. It's just a Spring MVC application. We write a lot of boilerplate for you, so you don't have to. So in that sense, if you would have backed it with a Spring MVC application before in custom code, then you can absolutely look at this as a replacement for that. You just don't have to write all the all of the CRUD handling code. That said, there still are some things that you need to be aware of deploying directly to the web. Because there's still some issues to sort out. Spring security, how does that apply? How do you secure your repositories, and how do you proxying issues? How do you protect it? Denial of service attacks, things like that. That you'd normally deal with in a production environment. But certainly, the short answer is it's a Spring MVC application, and absolutely could be used for single page apps. That was kind of one of the use cases we had in mind when we first started talking about this. Is how do we power those Android apps or iPhone apps or Ajax applications. So.
Okay.
The Kickstart stuff, did you mention that?
No, there's a question here, where's the best place? You can't access the Spring site. Well, that's kind of strange, but the resources I listed here are, these books, obviously. You have 2 books now on Spring Data which cover the repositories. And in terms of getting started, Spring Data book on GitHub, Spring Data Kickstart, Spring REST box, and Spring SQL Fire samples. These are all places to get started. The book ties into the book examples. Kickstart are sort of more naked, almost Maven archetype-like ways to get started. A lot of questions. I understand the question. Oh, there's a question of a Spring REST Shell plugin for STS that actually came up on a previous webinar. We should probably talk to our STS guys about getting that embedded. Seems to be a common request. Since JDBC template handles transactions for every query, how to handle transactions at the service level for batch process. So everything around transaction management that you've done with JDBC template applies to QueryDSL JDBC template. So you can use declarative transaction management. You can use all those features. I'm not 100% sure on the batch functionality in QueryDSL. I believe it has some functionality there, but remember a user. Yeah, QueryDSL supports JDBC batch updates. So you have to dig into the documentation on QueryDSL for that. Does REST support HTTPS? Yes. Any plans to integrate Spring Data, Spring Shell into Spring Roo? So that's a good one. Spring Data repositories are already part of Spring Roo. They're supported for JPA, for Mongo, and for Neo4j, as well as Gemfire. So Gemfire is coming. Yeah, so those are the 3 supported. We didn't mention it yet, but there is a degree of portability you can achieve with the repositories. Namely, if you have something like find by name and you have an appropriate mapping for Mongo of your domain object, the repository can be used across both of those. Let me just could post a little link for you. Here we go. This was done almost a year ago, actually. So there's a blog post that announced that. Okay, for non-Maven project with the basic Spring jars and configs need to implement so and so and so. So I'm assuming you're using some build tool, right? Maybe Gradle or Ant. If you're using Gradle, then it knows how to track dependencies. Otherwise, I'd say you should probably list them, I guess, but it's kind of a world of pain to make a Java project without Maven or Gradle or some dependency tool.
If you're not using it directly in your project, you could use one of these sample projects, like Spring Data REST-WebMVC on GitHub, on our Spring source GitHub, and just run a build of that, run an assembly of that, and then look at what jar files it copies in, and then you can get a pretty good idea of what you're going to need just from that.
Or then you can ask Maven or Gradle to spit out its dependencies, and it would spin that out. So is Spring Data a replacement of Hibernate? Absolutely not. Much like many things in Spring, it's a layer on top of JPA or Hibernate that makes it easier to use. I do not know what a DICOM PACS repository is, so if anyone wants to explain that. In terms of other technologies, we do encourage people to get involved, and there is Lucene support that is being run quite nicely through external party. So other repository implementations for other technologies are open, and we're happy to help external contributors. Does this new JDBC template support NoSQL? The answer is no. It's JDBC. It's not NoSQL. Firmly believe these two worlds don't mix very well. We do have dedicated NoSQL support you can find about in our upcoming webinar, Harnessing the Power of NoSQL. I mentioned earlier we support a wide range of NoSQL support. Here you can see Redis, HBase, Mongo, Neo4j, Lucene, and Gemfire. How Pageable handles the data. Can I configure the quantity of items per page? Yes, you can specify that. You can specify the first and the last page. Would you rather use JPA instead of Hibernate? It's a personal choice. So JPA works for you. You still have to pick a vendor, so you can pick Hibernate. It's probably the most common choice, but we actually do test consistently against all the major providers as well. In fact, I think we discovered some bugs Oliver did in Eclipse link, interestingly enough. It's a medical repository, so and so and so. I imagine if it's not JDBC-based, then you'd have to do a bit of work to have it be supported in the same style as these finders and so on. I don't know much about that database. This one referred to this very specific medical image database, or what the APIs are for that. Okay, I think that handles all the questions. I guess the last question was about 7 minutes ago. Would you rather use, the issue is using JPA at app servers? No. I mean, that's a very well-supported configuration. You don't have to use an app server to run a JPA application. A standalone Java main is fine as well. Okay, I'll go to the slide that shows the books. Okay, I'll do that. There you go. Alrighty, everyone. I hope you found that useful. Feel free to reach out to us with any questions, suggestions. We're more than open to hearing requests, and we're doing all of this in response to community needs to make your lives easier. So the more contact we have with our user base, the better off everyone is. Take care. Bye.